And it's pretty cool. I mean, so the motor works. It's weak, but don't forget it's got those little bitty magnets in there, and you could replace that with big ones and actually get some power off of it. I may do that somewhere down the line. You can see we've got some high voltage coming off of that, and yep, I can get a little pinch off of this, but it's wimpy. So that part of it was a success, and you know, that's what started the whole thing. Finding out that the circuit can be activated mechanically rather than with this power supply hooked up was an accident, and I just wanted to show it to my friends on the internet. So there you go. I think this is cool. This is a brushless motor running off the simplest circuit, one transistor circuit. So putting all else aside, this is worthwhile just in itself as far as I'm concerned. You can have a lot of fun with that. So let's go on to some of the other tests then. Okay, I'm going to try to take care of as many things as I can with this video. Before I use the scope for the next part of this project, this is for the guy who insisted for days that my videos were no good because I haven't showed that my scope is calibrated. So you can see the probe here is on ×1. The divisions are set at 1 volt per division, and the probe is hooked up to the standard, and so you can clearly see that there's 1 volt per division and a good square wave. So much for that. I'll hook this up and we'll do the motor test. At this point I've hooked the scope up to the windings that are on the 10 legs of the stator, which is my largest windings, and we have the window motor turning the stator motor generator oscillator at 1000 RPMs. I've adjusted to 13.914 volts. And we'll go over to the scope and look at the pattern coming off of the motor right now. And I have the divisions set to 5 volts per division, if you can see that. So we're getting about 8 volts plus and 8 volts minus, or 16 volts peak to peak AC. It's not outstanding. It's kind of a small voltage, but remember, this stator here and the rotor, they're equipped with those little bitty tiny magnets, and my goal wasn't to make a strong generator. It had nothing to do with the experiment. It's doing just exactly what I expected. I'll show you a little bit more about this DC current in a second. Or actually the AC, I'm going to rectify it and we'll take a look at it. Moving on, I've hooked a little bitty full wave bridge rectifier up to the motor and hooked the scope to the other side of that, and you get just exactly what you'd expect. Now everything is on the positive side, and so I've got a pulsating DC current that's about 8 volts. Now if I rectify that, if I filter it with a capacitor, which I'll try to do with one hand, I'll just hold the capacitor across the output from the full wave, and as you can see, the trace goes up to about 7 volts and it's smooth. If I disconnect, you can see what happens. So there you see the pulsating DC being filtered to 8 volts. Now, do you think this 8 volts would charge a 12 volt battery? Not. And it's a far cry from 400 too, isn't it? So much for the concept that, oh, you can get high voltage anytime you spin a DC motor. Spin it and the voltage comes pouring out the other side. Not quite. Not when it's running like a conventional motor, generator like this is. You can see what it can do with this RPM. So now we're going to hook it up to the other circuit. Alright, so far what we have in this video is something that I was too dumb to explain in the other one, or didn't have enough time in a 10-minute video, is we can take a salvaged office printer or copier machine motor and turn it into a motor. It can be a three-phase motor running from a three-phase circuit of any kind, even a model airplane brushless speed control. It can be modified. The coils can be modified on it to run from a pulse circuit. The motor also can be used as a standard generator. Even though this is a weak one for a special purpose, it could be a generator. So now it's time to go on and explain the Bedini SSG circuit as best I can. I'm not an expert, but let's have a look at it and it'll help explain things a little bit. This is the SSG circuit. It was originally named the Simplified Schoolgirl circuit because it was introduced in a science project, and I think a young girl ran a crank generator, an old Bell generator of some kind, as a motor for the length of the project on a 9-volt battery or something like that. I think they were probably charging something else as it was going. The circuit's very simple and inexpensive. It has one transistor and a few resistors, diodes, a little high voltage neon bulb there, and a little potentiometer for making adjustments to the circuit. Now, people are using this circuit successfully to charge batteries. Let's put aside the radiant energy and everything for a minute, because I have no way to prove whether this particular device is running and successful because of radiant energy or not. I can't measure it. I can't say it does. I can't prove it one way or the other, and I'm not here to try to. But I can show you that it'll charge a battery just the way it is. First of all, I've left the power supply at 13.9 volts where it was to run the other setup because I don't want to change it. And I've hooked the scope up to the output of the SSG circuit, and it'll run as a motor. It'll take off again. But let me show you something. Nothing is going on when I rotate this at this speed. Now if I go a little faster, you can see this neon bulb flashing, which has the capability of blowing out my transistor. But do you think this generator, which is this motor, which is almost identical to this one, is putting out that high voltage because it's a standard generator? I don't think so. Same small magnets that you've seen before, and you can see it takes 90 volts to light that neon bulb. Now the scope over here has the probe set to times 10, which is in this back position by my thumbnail. I'm on 5 volts per division, which means times 10, everything you see a division high is actually 50 volts. So when I give this these little pops, you can see the trace jumping up there. You know, that's probably several hundred volts. So this is sort of the standard operation of this circuit and some sort of an oscillator. Now this is the third part of this setup. Is the reason for the small magnets is I don't need to make a lot of voltage and current. I only need to make enough from this little trigger coil to fire this transistor, which drives the bigger coils in here and gets the motor into rotation. As it rotates, it becomes an oscillator, and the coils are turned on and off and pulsed with whatever current you have and voltage coming into the circuit. So if I spin this up, it's going to run and it'll charge something. I'll do that. 9 volts. I'll switch back to what it was before we go on with the other experiments. What I need to be able to show you is that we can charge the 12-volt battery with less volts, like a 9 volt input to this